C++ templates. The topics of discussion are: what are C++ templates? The two types of C++ templates, the function template and the class template. Two C++ standard templates for linear data structures, which are the vector and the list. Now let us see what are C++ templates and its types. C++ template is a concept which facilitates reuse of code for different data types. That is, how we reuse the functions and the classes for different data types. The two types of C++ templates are the function template and the class template. Function template is a methodology to use the C++ functions for different data types. The definition of the function template depends on the user-defined data type. The compiler determines the data type of argument during the execution of the function call. Let us see an example of C++ function template. Defining function template requires the use of user-defined data type, which is replaced by the C++ predefined data type during the function call. In the example given here, we have defined the user-defined data type item using the template statement, and which is identified by the keyword class or type name. The function maximal receives argument a and b of data type item and returns the value of data type item. The function template maximal finds the greater value between a and b. As an example, we have given two function calls to the function maximal. The first function call maximal 100, 3000 represents the function maximal could be used for the data type integer. The second function call maximal 3.4, 69.567 represents the template function maximal can be used for the data type float. Hence, once the function template is defined, it could be used for different data types. Here are two more examples of function template. In example 1, we have defined two user-defined data type item and size type using a single C++ template statement. The function template index underscore of underscore maximal receives two arguments, the data array and n of type item and size type respectively. During the function call index underscore of underscore maximal d, 12, the data type of data array is the data type of d and the data type of n is integer because 12 is passed from the function call. Example 2 is very similar to example 1. We have defined two user-defined data types item and size type using a single C++ template statement. We have defined a function template ordered underscore insert which receives three argument data array n and entry of type item, size type and item respectively. The function call ordered underscore insert d, 3, 15 determines the data type of the arguments during the function call. Class template is a methodology to use C++ class for different data types. That is, the member variables of the C++ class can take different data types. The compiler determines the data type of the member variable during object creation. The syntax for class template is as given here. We use the template statement to define a user-defined data type. Here, uppercase T is defined as a user-defined data type. The member variables are declared using the user-defined data type T. Apart from the predefined C++ data type used by the member functions, the member function of this class can use the data type T to receive arguments and return values. During object creation, between the greater than and the less than symbol, the data type of the member variable is defined. In the example given here, the data type of the member variable is integer for object C1 of type class name. Class template example. The C++ class calculator is an example of class template in which its member variable num1 and num2 are defined with the user-defined data type T. It has member function add, subtract, multiply and divide, which does respective operations for these member variables num1 and num2. In the function main, we have created two objects C1 and C2 of type calculator. When C1 object is created, the member variables num1 and num2 are defined of data type integer. When C2 object is created, the member variables num1 and num2 is defined of data type float. Hence, during object creation, the data types of the member variables is determined when the class is defined as a class template. We have discussed how to create user-defined function template and class template. Let us see two C++ standard templates for linear data structures. The two C++ STLs for linear data structures are vector and list. To use vector STL in our program, we have to include the vector library in the program. Vector is a container that can store elements as an array, but its size can change dynamically. All elements will remain in the same order in which they are inserted. Similarly, to use list in our program, we have to include the list library, and the linked list is implemented using the list container in C++. Let us see an example of using vector as well as list. This is an example C++ program using vector STL. The program includes vector and iterator library. Iterator provides an object by which the elements of the vector could be browsed. VEC is an object of type vector which uses values of data type integer. We create an iterator object for the vector using the statement vector int scope resolution operator iterator it. It is an object for VEC which helps to browse through each element in the vector VEC. Pushback is a function provided by the vector library which inserts value in the vector. Using the begin and the end function of the vector, the iterator is used to browse through each element in the vector. The number of elements in a vector can be obtained using the size function. The elements in the vector can be printed in the reverse order using the rbegin and rend function along with the iterator. The emptiness of the vector can be obtained using the empty function. The elements in the vector can be obtained randomly using array-like statement as VEC within square brackets the index of the element which we require, or we can use the at function to get an element at a particular index. The front and the back function gets the first element and the last element respectively from the vector. List is a standard template library provided by C++. It is a linked list library and it acts as a double-ended queue where insertion and deletion happens at the front and the rear end. To use the list in the program, the list and the iterator libraries are included in the C++ program. In the example given here in function main, LT is an object of list which holds data values of data type integer. LT2 is also an object of list which holds the data values of data type integer, but it is initialized during its creation with values 2, 4, 6, 8 and 10. Apart from inserting values during creation of the list, we can also insert values one after the another like we did in the vector. The insert function inserts values in the list. That is, it inserts value at the rear end of the list. The begin and the end function along with the iterator helps to browse through each element in the list. This is also very similar to the vector. The function pushback inserts value at the rear end of the linked list and pushFront inserts value at the front end of the list. Similarly, elements can be removed from the rear end using the popBack function and from the front end using the popFront function. The sort function arranges the linked list elements in the ascending order, and the linked list can be merged, that is, can be combined using the merge function. Summarizing, in this presentation, we have discussed about C++ templates, the types of C++ templates, and two C++ standard templates for linear data structures. We have discussed in detail the C++ programs that use vector and list, the standard template for linear data structures. Thank you.